This is the second part of section 3.6, transformations of graphs of linear functions. In the first part, remember we visited about translations. One type of transformation was translations, which is just a slide or a shift of a graph. The second transformation was a reflection, where we flip the graph over a line, usually the x or the y axis. In this second part, we're going to talk about the third different type of transformation, and that would be a stretch or a shrink. Okay, so horizontal shrink, horizontal stretch, vertical shrink, vertical stretch. Four different types of stretches and shrinks, two in the horizontal direction, two in the vertical direction. Okay, so a horizontal shrink is when the graph shrinks toward the y-axis. A horizontal stretch is when it stretches away from the y-axis. So if we think about the xy plane, okay, a horizontal shrink, everything goes this way. In a horizontal stretch, everything goes that direction. Okay, in a vertical shrink, everything goes toward the x-axis. Actually, let me get rid of that second arrow. We'll go this way. That's a vertical shrink. So let me underline these in different colors. So horizontal shrink was in red. Horizontal stretch was in purple. Vertical shrink was in green. And then vertical stretch will be in blue. So everything gets farther away from the x-axis. Okay, so that's what everything's doing here in these stretches and shrinks. Now, if you remember in the first video, I made a couple of tables, and I've got another table here for you for stretches and shrinks. Okay, so horizontal will be on the left, horizontal, vertical will be on the right. Okay, so for a horizontal shrink, the notation y equals f of ax. Remember, in the reflection and the translation, everything that was horizontal was directly to x. With stretches or shrinks, it is no different. Okay, everything is going to be directly to x. With vertical, y equals a times f of x. Remember, with vertical transformations, whether it was a translation where we slide it or a reflection, it was on the outside of the function. And with vertical stretches and shrinks, it's no different. Okay, so within horizontal, we're on the inside. Now, with the horizontal shrink or stretch, what we're doing here is we're multiply x by the reciprocal. That's a huge key to this, reciprocal. The reciprocal of the factor, okay? It's the reciprocal of the factor. With the vertical, we multiply the entire function by the factor straight away. Okay, because remember, with horizontal translations, if we had -3, it was actually 3 to the right. Same idea here. It's everything with horizontal transformations is going to be kind of backwards. Okay, so we're multiplying x by the reciprocal of the factor with horizontal stretches and shrinks. And I've got a couple of examples here to explain that. With both stretches and shrinks, regardless whether it's horizontal or vertical, if your factor, if it's bigger than 1, let me just do this, bigger than 1, what that is, if I asked you what that was, that would be a stretch. Whether it's horizontal or vertical, it doesn't matter. If the factor is bigger than 1, it is going to be a stretch. Whether it's horizontal or vertical, it doesn't matter. If your factor is between 0 and 1, between 0 and 1, that is going to be a shrink, okay? Whether it's horizontal or vertical, doesn't matter. A factor bigger than 1 means it's a stretch. A factor between 0 and 1 is a shrink, both horizontally and vertically. Okay, so let's try a couple of examples here. Number 1, let f of x equal -3x plus 4. Part number 1 says graph g of x equals f of 2x. Describe the transformation from f to g, and then we'll do the same thing with number 2. Okay, so with number 1, the number is inside the parentheses, and if it's inside the parentheses, that is going to be a horizontal transformation. Horizontal. We'll leave the space here for a second. So that's either in this space right here, it's either going to be stretch or shrink. And let's figure out the factor. By the factor of what? Well, we're multiplying x. If we go back, whoops, if we go back, we multiply x by the reciprocal of the factor. Okay, so if the number here we're multiplying x by is 2, we need the reciprocal of that. And the reciprocal of 2 is 1/2. Remember, reciprocal just means flip over the fraction. So kind of as a side note, 2/3, the reciprocal of 2/3 would be 3/2. The reciprocal of 1/4 would be 4/1, or just 4. Or if we had 1/3, then the reciprocal of that is not 2, sorry, it would be 3. Okay, so just a couple of examples of what reciprocals are. Okay, so our factor here for number 1 is 1/2. If the factor is between 0 and 1, like this one right here, that means it is horizontal shrink by a factor of 1/2. And I'll show you what the graph looks like here in just one second. Number 2, graph h of x equals 1/2 times f of x. Describe the transformation. Now the 1/2 is on the outside, so that is a vertical something by a factor of what? Well, if it's vertical, we multiply the entire function by the factor itself. Okay, so this is the factor, the 1/2. So the factor is 1/2, and again, if the factor is between 0 and 1, it is a shrink. It's a vertical shrink by a factor of 1/2. So let's go ahead and bring in some graph paper, and let's try graphing this. All right, so here's my xy axis. Whoops. Let's try that again. There we go. Okay, so the original function was negative 3x plus 4. I'm just going to write that out here, negative 3x plus 4. So we start at 4, my y-intercept, and my slope is negative 3. So that means down 3 and then to the right 1, down 3 and to the right 1, down 3 and to the right 1. Do you need all these points? No. Instead of going up into or down and to the right, we could go up and to the left. So we'd have another point there, and then we can draw the line between them. Not a very good line, but we can go with it. This is f of x, the original problem. All right, so now, the number 1, horizontal shrink by a factor of 1/2. If I look at this point right here, we're thinking horizontal. So the shrink factor is 1/2. So we want to be half as close to the x-axis as we originally were. Sorry, this is horizontal, so we're going to the y-axis. My bad, we're going horizontally. So if this was 2 away, half of that is now 1. So this is going to be now 1 unit away from the y-axis. If we look at this point right here, if this is 1 unit away, so half of that is 1/2. So we're going to be right here. Okay. This point right here is on the y-axis, so half of 0 is still 0, so that point isn't going to move. This point right here is 1 away, so half of 1 is 1/2, so that's going to be there. And then we got this point right here. This is 3 away, so half of 3 is 1.5. So here are the points for that first question. Okay. Hopefully you can see this is g of x. Hopefully you can see that we have shrunken everything towards the y-axis. Okay. Number 2, vertical shrink by a factor of 1/2. So now we're comparing things to the x-axis. We're going vertically. So this point right here is 2 units away from the x-axis. So half of 2 is 1. So that point's going to be there. This point right here is 1 unit away. So half of 1 is 1/2. Okay. This point right here is, let's see, 1, 2, 3, 4 units away. So half of 4 is 2. So that point is now going to be there. This point, let's see, so this was 4, 5, 6, 7. So half of 7 is 3.5. So 1, 2, 3.5 is there. Okay, and then we got this point right here, 1, 2, 3, 4, 5 units away. So half of that is 2.5. That would be right there. And we can draw our graph. We're getting closer to the x-axis. This is h of x. Now my picture's not that great. Obviously you can see that there's some issues with the squiggly lines, but if you graphed it with a graphing tool, or more exactly on a graph paper with a ruler, you should see that things kind of get stretched out, or shrunken down in this case, to both the x and the y-axis. All right, let's try another one here. Let f of x equal negative 2x plus 2, and then number 1, g of x is equal to 3 times f of x. And number 2 is h of x is equal to f of 1/3 x. Describe the transformation from f to the new functions. So with number 1 here, we're multiplying the original function by 3. If it's outside the function, that means it's vertical. Vertical something by factor of If it's vertical, the number on the outside is the factor, so it's a factor of 3. And if the factor is bigger than 1, that means it is a stretch. It's a stretch by a factor of 3. For the second one, 1/3 is on the inside, so if it's on the inside, that is horizontal. Horizontal, we'll leave the blank here, by factor, whoops, let's try to clean that up a little bit. Factor of, now this is, we're multiplying x by the reciprocal of the factor. This number is 1/3, so the reciprocal of 1/3 is, well, it's also 3. So if it's a factor of 3, it's also going to be a stretch, okay? Horizontal stretch by a factor of 3. So let's bring in some graph paper. Whoops, that's supposed to be 2 fingers. Sliding that up, my bad. And let's go ahead and draw in, whoops, draw in our XY plane here. All right, so we got the XY plane. The original function was negative 2x plus 2. Just write that off to the side, negative 2x plus 2. So we start here at positive 2. Slope is negative 2x, so that's down 2 and right 1, down 2 and right 1, down 2, right 1, or it could go up 2 and left 1, so it'd be a point there, up 2, left 1 is right there. Okay, so this right here, let's draw it a little better. This is f of x. This is our original problem. Now, number 1, vertical stretch by a factor of 3. Now, I'm not going to be able to get all of these points on this graph because we're going to get really narrow here. All right, so this point right here, the y-intercept, how far away from the x-axis, because we're talking vertical, it is 2 units away. I want it to be 3 times that far, so 2 units away times 3 is now going to be 6 units away. So 2, 4, 6, this new point is going to be right here. Okay, we're getting very much farther away from the x-axis. This point right here is on the x-axis, so that's 0 units away, and then 0 times 3, well, that's still 0, so this point is going to remain. This point right here, 2 units away, so we want to triple that, so now it's going to be 2, 4, 6 units away, so that's down here. And then, actually, let me try redrawing that right on the mark. I don't know that I'm going to get anything else on this graph. Sorry about that. That was Mr. Flanagan making an announcement. So I've got my points that I can graph. This point right here is 4 units away from the x-axis. Triple that would be 12 units. It's going to be way up here back in the letters, so I'm not going to be able to draw that one. I'm just going to go with these 3 points. Okay, it's going to be a very steep line. This right here is g of x. All right, let's go ahead and do number 2, horizontal stretch by a factor of 3. So now we're talking this direction, left and right. All right, so this point right here is on the y-axis, so that'd be 0 units away from the y-axis. 0 times 3 is still 0. We're not changing. We're not moving that one. This point right here is 1 unit away from the y-axis, so 3 times that would be 3 units away, so that's going to be out in here. This point over here is 1 unit away, so we're going to go 3 units away then, so that's going to be over in here. This point right here is 2 units away, so 2 units times 3 is now 6 units, so 2, 4, 6. That point is going to be right in, let's see, 3, 4, 5, 6 is going to be right here. And then we can do this point as well, so this is 2 units away, so 2, 4, 6 is going to be right over there. So let me make that mark. 3, 4, 5, 6 is there. And then if we wanted to, we could do this point as well, so this is 3 units away. So then times 3 is going to be 9 units away. So 3, 4, 5, 6, 7, 8, 9 units away. It's going to be right there. And we'll have our, whoops, our new line here. Again, excuse the wiggly, wobbly lines, but if you used a ruler and a little steadier hand, you should see the new lines. Okay, so there's a couple of examples of stretching and shrinking things horizontally and vertically. Hopefully that makes a little bit of sense to you. Moving on to the final topic in section 3.6, multiple transformations. So we talked about each one individually. Now let's talk about, well, what if we've got more than one? The rule here is to follow the order of operations, PEMDAS. Okay, the first thing we're going to do here, translate left to right. So we got to do what's inside the parentheses first. So follow the order of operations. There won't be any exponents, so we can skip the E. Multiplying and dividing, so that would be the vertical stretch or shrink. Okay, that's where the multiplication comes from. If this number is negative, go ahead and reflect it over the x-axis because it would be outside the original function. Okay, so it would be a reflection. We can make this little note. This would be over the x-axis. okay? And then the last thing would be translate up or down, the adding or subtracting, okay? So let's do an example here. Graph f of x equals x and g of x equals negative 2x plus 3. Describe the transformation from f to g. Now, we know that f of x is equal to x, and we have an x in our new function. So what I'm going to do, I'm going to take this, and I'm going to swap x with f of x. So g of x is equal to negative 2 times f of x. I'm going to get rid of the parenthesis there. Negative 2 times f of x plus 3. Okay, so now hopefully that makes a little more sense when we think about our rules. So we need to do the order of operations. So let's describe the transformation first. There's nothing inside the parentheses, so there's no translating left or right. We don't have to worry about that. Okay, so there's no translating left or right. So now we can move on to multiplying. So these two were kind of together. Obviously this is multiplying by 2. We're multiplying the entire function by 2, so it's a vertical stretch by a factor of 2. Okay, the fact that it's negative, also means it's a reflection in the x-axis. Okay, that takes care of the negative 2, and then the last thing is the plus 3. So that's the translating up or down. Remember, if it's translating up or down, the sign tells you which direction. If it's plus, it's a translation 3 units up. Okay, 3 units up. Now I'm actually going to put 3 lines on the graph, but the third line is going to be the final answer. So we're going to graph the original function f of x equals x, and then we're going to graph the final answer will be this one, negative 2x plus 3. Okay, so let me bring in some graph paper here. Let's draw the coordinate plane. Whoops. All right, so the original one was f of x equals x. So that means the slope is 1 and the y-intercept is 0. So I'm just going to start at 0 on my y-axis, go up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1 every time. Okay, and we can draw the line in between. Okay, so this is f of x. Okay, now I'm going to do the blue transformation first. Vertical stretch by a factor of 2 and a reflection in the x-axis. All right, so this point right here, from the x-axis is 0 units away. Okay, so it's not going to move anywhere. Then when we reflect it, it's already on the x-axis again, so it's not going to move at all. Okay, this point right here, 1 away from the x-axis, so now it's going to be 2 away. And then when we reflect it, if it's 2 above, it's going to be reflected down to 2 below. This one's going to look like this. Okay, with this point right here, it's 2 above, so when we stretch it by a factor of 2, we're going to be 4 above, and now if we're 4 above, when we reflect it, we're going to be 4 below, so this point now goes right there. I'm going to go to the other side. This point right here, 1 away from the x-axis, so when we stretch it by a factor of 2, it's now going to be 2 away, and then when we reflect it, since it's 2 below, when we reflect it, it's going to now be 2 above. Okay, so we're going to have another point. This point right here, 2 units away from the x-axis, so we'll stretch it to make it 4 units away. And then since it's 4 units below, when we reflect it, it's now going to be 4 units above. Okay, so there are our points for the blue transformation, a vertical stretch by a factor of 2. Now, for the final answer, we need to do this line here in green, translation 3 units up. We're going to take these blue points and we're going to do a translation 3 units up. Basically, or not basically, what we're going to do is slide them all 3 units up. So from this point, I'm going 1, 2, 3 units up, so that point is now going to be right here. Same thing with each of these points, this one, this one, this one, and this one. Go 3 units up, so 1, 2, 3 puts me right there. 3 units up from the origin is right there, and then 3 units up, and then 3 units up. These 5 points of this line that I'm going to draw here in green, this is our final answer. This is now g of x. Okay, so I think the blue points are important because that helps us kind of stay organized, kind of lists out our transformations and allows us to go step by step. The actual final answer here is the green line. Okay, we want to graph f of x equals x. That's what we did in black, and then we want to graph negative 2x plus 3. That's after we do our transformations. We got a slope of -2, y-intercept of 3. So we can double check ourselves if we need to.